In this video, we want to look at scalar and vector quantities. Scalar and vector quantities. What we want to look at in this video, learning outcome. Learning outcome. At the end of this video, you will learn scalar quantity. We know what scalar quantity is all about. Vector quantity. You will understand vector representation. You will know the types of vectors. You will understand resultant vector, resolution of vectors, and resolution of more than two vectors. So this is the learning outcome of this class. Okay, what is scalar? What is scalar quantity? In my earlier video, I have discussed what physical quantity is all about. So you can look at it to have idea more about physical quantity. So scalar quantities, they are physical quantities that have magnitude only. Physical quantity that has magnitude only. And by magnitude, we mean size. There are some physical quantities that have only magnitude. An examples are mass, distance, speed, pressure, energy, volume, density, and many others. So all these are examples of scalar quantity. Okay, let's look at the other one, vector quantity. Vector quantities, they are also physical quantities that have both magnitude as well as direction. So magnitude and direction. So anytime we talk about vector quantity, the two things that come to mind is the magnitude or the size and the direction. Examples of vector quantities are weight, velocity, acceleration, momentum, displacement, etc. So all these are examples of vector quantities. They have magnitude as well as direction. Then let me clear this. We say example of scalar quantity is speed. Example of vector quantity is velocity. In most cases, we use speed and velocity interchangeably. But speed and velocity, as far as this topic is concerned, they are not the same. What is speed? Distance traveled over time taken. What is velocity? Velocity is displacement over time taken. So the major difference here is distance and displacement. So what is distance? What is distance? Distance is the actual length between 2 points. If you have point A, point B, the actual length between these 2 points is what we call distance. And the unit is meter. Then displacement. What is displacement? Displacement is the distance traveled in a specified direction. So the major difference between speed and velocity is in terms of distance and displacement. And we say distance is the actual length between 2 points measured along a specified path. The distance between 2 points measured along a specified path. Why we say displacement is the distance moved in a specified direction. So the major difference between speed and velocity is that in case of velocity, the direction is specified because of displacement here, while in the case of speed, it is not. Meanwhile, the unit of distance is meter, the unit of time is seconds. The unit of displacement too is meter, the unit of time is second. So they both have the same unit, meter per second. So velocity is a vector quantity, while speed is a scalar quantity. Okay, let's make progress. We want to look at vector representation. Having known what is vector, how do we represent vector is what we are looking at. Earlier, I have said that the major component of vector is magnitude and direction. So, we use vector or arrow diagram for vector representation. So we are looking at vector representation. How do we represent vector in terms of the magnitude, in terms of direction? So what we use to represent vector, we call it vector or arrow diagram. So the length of the vector is denote its magnitude, while the arrow shows the direction. So for vector representation, in terms of the magnitude, we use the length to represent it, while in terms of direction, we use an arrowhead like this to show the direction. So this vector is in the direction of east. You can have vector in the direction of north, vector in the direction of south. So this is how we represent vector. And using letter, you write the letter, then you put an arrow bar on top. So this is vector A. So this is how we represent vector. Okay, let's look at the next thing, types of vectors. Having known how we represent vectors, the next thing we want to look at is types or kind of vectors. There are different types, there are different kinds. So let's look at types of vectors. Types of vectors. We have equal vectors. Equal vectors. If you have two vectors of the same magnitude pointing in the same direction, the two vectors, they are equal vectors. So if this is vector A and this is vector B, we can say that these two vectors, they are equal. The second one, we have negative vector. Negative vectors. Two vectors are said to be negative if they are in opposite direction. You have vector A in opposite direction to vector B. So these two vectors, they are negative vectors. Then the third types of vectors that we have is null or zero vector. Null or zero vector. If you find the magnitude of a vector and the answer is equal to 0, that type of vector is called null or zero vector. A vector whose magnitude is equal to 0. We have other types, proper vector. What is a proper vector? A proper vector is a vector whose magnitude is not equal to 0. Then the other one we have here is unit vector. Unit vector. A unit vector is a vector whose magnitude is equal to 1. So these are the various types of vector that we have. The unit vector, a vector whose magnitude is equal to 1. So these are the various types of vector that we have. Okay, the next thing we want to look at, resultant vector. Resultant vectors. What is a resultant vector? From, as the name implies, resultant, from result. So if you have two or more vectors, the result gotten from them, the single vector gotten, either from by addition or subtraction, we call it resultant vector. So resultant vector is the single vector obtained by adding or subtracting two or more vectors. So that leads us to addition of vector and subtraction, addition and subtraction of vectors. So the single vector gotten from addition or subtraction of two or more vectors, we call it resultant vectors. So how do we add two or more vectors together? If you have two or more vectors acting in the same direction, the resultant is to add them together. So in adding vector, if you have two vectors, vector A acting in the same direction as vector B, all we need to do, the resultant, is to add two of them together. Resultant vector A plus vector B. And if they act in opposite direction, vector A is acting in this direction, vector B is acting in this direction. So the resultant, you subtract vector A minus vector B. So this is how we find resultant of vector, by addition or by subtraction. So let's look at some example to find the resultant of two or more vectors. Example. Okay. Example 1. Find the resultant of two vectors A and B of magnitude 50 Newton and 20 Newton respectively, acting in the same direction. So this is the equation. We are to find the resultant. Two vectors A of magnitude 50 Newton and vector B of magnitude 20 Newton, acting in the same direction. So we have the first vector, 50 Newton vector A, 50 Newton. Then we have vector B. Vector B and is 20 Newton. So the resultant is that we add them together. The resultant will be vector A plus vector B. So that will be 50 plus 20 equal to 70 Newton. So the resultant vector R is equal to 70 Newton. So this is how we add two or more vectors together. Okay, let's look at the case of subtraction. Another example. Another example. Vector A of magnitude 60 Newton acts in opposite direction to vector B of magnitude 15 Newton. Find the resultant of the vector. So here we have two vectors, but this time around they are acting in opposite direction. Vector A, 60 Newton, vector A, 60 Newton, vector B, how many Newton? 15 Newton. So we are to find the resultant. Since they are acting in opposite direction, the resultant will be A minus vector B. 60 minus 15, 45 Newton. So this is how we subtract two or more vectors. So this is the resultant of these two vectors. Remember, we say resultant vector is the single vector gotten as a result of what? Addition or subtraction of two or more vectors. Okay, let's proceed. Let's proceed. We have looked at addition of two or more vectors. When two vectors are inclined to each other, the resultant is not an ordinary arithmetic sum, but a vector sum. So what we are saying is that in the case of addition, subtraction of vectors, the approach we have seen. However, at times one vector will be inclined to another at an angle. You have vector A inclined to vector B at an angle theta. So in this case, the addition or subtraction of the vector is not by arithmetic means like we just did. It is by vector sum. And the method used include Pythagoras theory. Pythagoras theory, we have three of the method. The second one is parallelogram law. Parallelogram law. And the third one is triangular law. So these are the three approaches that we use to find the resultant vector of two or more vectors that are inclined at angle to each other. So the method used, we use Pythagoras theory, parallelogram law, and triangular law. So let's look at each of them. How do we use Pythagoras theory to find the resultant of two or more vectors? According to Pythagoras theory, if you have two vectors, Pythagoras theory, if you have two vectors, vector A and B, acting at right angle to each other, two vectors acting at right angle to each other, vector A, vector B, acting at what? Right angle to each other. So how do we get the resultant? This is the resultant vector, then the direction. So according to Pythagoras theory, that if you have a right angle triangle, if this is A and this is B, then the resultant R is equal to A square plus B square. Then the angle opposite over adjacent, tan theta equal to opposite over adjacent. So angle theta now will be equal to tan inverse opposite over adjacent. So according to Pythagoras theory, this is how we find the resultant and also the direction. Remember, we said vector, they are physical quantities that have both magnitude and direction. So we use Pythagoras theory to find two vectors that are at right angle to each other. And what is the approach? This is the approach. Two vectors at right angle to each other, as we can see, vector A, vector B. You see this line. We trace it down. From here, we get this shape. So this is the resultant vector. This is the angle. So using Pythagoras theory, we are able to get the resultant vector and also the direction. So let's look at one or more example for us to better understand how we use Pythagoras theory to find the resultant vector. We are looking at example. A boy running in the northern direction later changed his direction and started running towards the eastern direction. If the distance he covers in the northern direction is 4 kilometers and in the eastern direction is 3 kilometers, determine the magnitude of his resultant and his direction. Okay, let's look at it. A boy running in the northern direction, covering distance of 4 kilometers, changing his direction to the eastern direction, covering a distance of 3 kilometers. We are to find the resultant. This is the resultant, R, and also the direction. So, if you look at it, the angle between the two vectors, it is at right angle to each other. So based on this, we apply the Pythagoras theory. And according to it, the resultant will be 4 square plus, from the formula, 4 square plus 3 square, square root, 16 plus 9 equal to 25. Square root of 25 is 5 kilometers. So this resultant is what? 5 kilometers. So the next thing we have to find the direction. And the direction theta is tan inverse of 3 over 4. So which will be tan inverse 0.75, and that will give us 36.86 degrees. So from here, we have known the resultant and also the direction with which the boy is moving. Okay, let's look at another example. Let's look at another example. Example 2. Okay, let me read out the question. A cross-country skier skied 1 kilometer north and then 2 kilometers east on a horizontal snow field. How far and in what direction is she from the starting point? So it's a similar question. The first distance covered is 1 kilometer. 1 kilometer north, and it changed direction, covering a distance of 2 kilometers. So the question says how far, this is the starting point, how far from the starting point, which is the resultant, and in what direction. Looking at it, the angle between it is what? 90 degrees. So we use Pythagoras theory. The resultant, this is the angle. The resultant will be what? Resultant displacement will be square root 1.0 square plus 2.0 square. So if you simplify, 1 plus 4 equal to 5 square root. If you simplify that, you will have 2.2 kilometers. So how far from the starting point is 2.2 kilometers? I hope we understand. Then the next thing is the direction. How do we get the direction? The direction here is theta. So we have theta is equal to tan inverse of what? 2.0 over 1.0. So that will give us tan inverse of 2. From here, the angle will be, to simplify, 63.4 degrees Celsius. So from here, we have gotten this, 63.4 degree. So this is how we solve resultant vector using Pythagoras theory. I hope there is no challenge. For each question you have, all you need to do is to see how, based on the magnitude, the direction, from there, using Pythagoras formula to get the direction and the angle. I believe it's simple. Okay, let's look at the second one, the parallelogram law. Parallelogram law of vector. Parallelogram law of vector. Okay, let's look at it. What is it all about? The parallelogram's law of vector states that if two vectors are represented by the adjacent side of a parallelogram, then the resultant of these vectors is given by the diagonal of the parallelogram. So this is what we are saying, that if you have two vectors represented by the diagonal side of the parallelogram, let's say vector A and vector B, if they are represented by the adjacent side of the parallelogram, then the resultant vector R will be represented by the diagonal of the parallelogram. Are we together? So this is the parallelogram law of vector. And this is what we use to find two vectors that are inclined to each other. So according to the parallelogram law, if you have two vectors, A and B, at an angle theta to each other, then the diagonal of each is the resultant vector. So this is the resultant vector. And from here, we can have, let's complete the shape of the diagonal. From here, this is theta, and adjacent side is equal. Angle on the straight line is 180, so we have this 180 minus theta. So we can use this. This is a parallelogram, if you are familiar with the shape of a parallelogram. So to find the resultant, this is the resultant. To find the resultant, we make use of cosine rule. And according to cosine rule, that the resultant square is equal to vector A square plus vector B square plus 2 times AB cos 180 minus theta. So this is what we are saying, that this resultant is equal to, according to cosine rule, is equal to the magnitude vector A plus vector B plus 2 times vector AB cos the cos of this angle. Remember, we say anytime we talk about vector, talking about the magnitude and also the direction. So this is the formula that we use to compute resultant of a vector that is inclined to each other using parallelogram law of vector. Then, to find the direction, we use sine rule. And according to sine rule, if you remember our mathematics, that if you have an angle, let me draw it very well. If you have an angle a triangle of this nature. Let's say A, small a, angle A, angle B, small b, angle C, small c. According to sine rule, that sine A over small a is equal to sine B over small b equal to sine C over small c. So this is the approach that we use to find the angle. Are we together? So let's look at an example for us to better understand. So the parallelogram law, we get the resultant using cosine rule, and this is the formula for cosine rule. While we get the direction using sine rule, and this is the formula for sine rule. Okay, let's look at an example for us to better understand what we are saying. Let's solve one or two examples. Remember, we are looking at parallelogram law of vector. Okay, let's take this example. What is the resultant and direction of two forces, A and B, with magnitude of 10 Newton and 15 Newton respectively, acting at a point at an angle of 55 degrees? Okay, we have 2 points, A and B, two forces, A is acting at 10 Newton, B is acting at what? 15 Newton. So at an angle 55 degrees. So if we look at it from the parallelogram law of vector, that if two vectors are represented by the two diagonal sides of a parallelogram, then we can find the resultant, which is the diagonal, and also the direction. Okay, applying the parallelogram law, let's redraw the shape. If we redraw it very well, we'll have something similar to this. So let's look at it. This is A, 10 Newton, 15 Newton, and the angle here is 55 degrees. So from here, this 55 adjacent angle is equal. An angle on a straight line is what? 180. So from here we can subtract to get this angle now. It's 180 minus 55. So we have 125 degrees. So this angle now is 125 degrees. So we have to find the resultant. This is the resultant vector. So we have to find the resultant and also the direction. To find the resultant and the direction. Let's represent the direction with phi. Okay, so to find the resultant using cosine rule, the r square is equal to a square, vector a square plus vector b square plus 2ab cos 125 degrees, this cos. So from here, let's simplify and see. You have 10 square plus 15 square minus 2 times 10 times 15 cos 125 degrees. So we introduce negative here because this angle is in the second quadrant. Are we together? And in second quadrant, cos is negative. That is why we introduce this negative here. So if you simplify this, you have 100 plus 225 minus 300 cos 125 degrees. So if you simplify this, you have the resultant to be 22.30 Newton. So, if you simplify this, remember, this R square. This R square, I mean. So, if you remove the square root and you simplify, R will be 22.30 Newton. So this is the resultant of the vector, 22.30 Newton. So we have gotten the resultant. The next thing is the direction. How do we find the direction? To get the direction, which is phi, so the direction phi in degree, using sine rule, we will have that sine phi over 10 is equal to sine 125 degree over 22.30. So we are looking for sine phi. So if you simplify, 10 sine 125 degree over 22.30. So phi will be equal to sine inverse of 10 times sine 125 degree over 22.30. So if you simplify further, you have approximately 22 degrees. So this is the approach, and the sine rule, like I earlier explained, sine of this angle over this times sine of this angle over this. And you know this is parallel to this. So if here is 10 Newton, here also is 10 Newton. So that is what we use here. Sine of this angle over this equal to sine of this over this. So we simplify, and at the end, we have gotten the direction. So based on this, we have the resultant vector to be this, and also the direction to be this. I hope it's not difficult. Okay, let's make progress. The next thing we want to look at is resolution of vector. Resolution of vector. We have looked at resultant vector. So we want to look at resolution of vector. Resultant vector and resolution vector, are they the same? Let's look at it to see whether they are the same or they are different. So resolution of vector is what we are looking at. Okay, if you recall, we have earlier said that two or more vectors can be added together or subtracted to give a single vector called resultant vector. It is also possible to carry out the reverse process and convert a single vector into its various components. This process is known as resolution of vector. Okay, let me explain. This is what we are saying. You have two vector, let's say Vy, V in vertical component, V in horizontal component. And this is the resultant vector. And this is the angle. So before now, we have seen that you can use the vertical, the horizontal component to find the resultant. So in the resultant vector, in the case of resolution of vector, we are saying that you can go in the reverse direction. We can go in the reverse direction. And how do we do that? From the resultant vector and the direction, we will be able to resolve this vector into vertical component and into horizontal component. So this sketch, we can have it like this. This is the angle. This is the resultant. This is the vertical component. This is the horizontal. So from here, opposite over adjacent is what? Tan. Opposite over hypotenuse. Opposite over hypotenuse is sine. So sine theta will be Vy over Vr. So from here, we have Vy to be equal to Vr sine theta. So we have gotten Vy to be this. So this is the vertical component, sine theta. Okay, if we also look at it, adjacent over hypotenuse, that one is cos. Adjacent over hypotenuse is cos. So we can have that cos theta will be Vx over Vr. So from here, we will have that Vx is equal to Vr cos theta. So we have resolved this, the horizontal component, to be Vr cos theta. So what we have done here is that if you are given a resultant vector, what we are saying, that in the case of resultant vector, you can take the vertical, the horizontal, and get the resultant and the direction. So in the case of resolution of vector, you use the resultant and the angle to get your component. As we have seen, we have get the vertical component in terms of the resultant and the angle, and also the horizontal component in terms of what? The resultant and the angle. So this, we call it resolution of vector. Remember, we said resolution of vector, we can convert a single vector. This is the single vector into its various components, the vertical component, the horizontal component. And this process, we call it resolution of vector. Okay, let's look at an example for us to better understand it. Example. Okay, let me read out the question. A boy using his slingshot to shoot a stone into the air at an angle of 30 degrees to the ground. The stone travels with an initial velocity of 10 meters per second upon leaving the slingshot. Resolve the velocity of the stone into its component. So how do we do this? We have a boy who is using a catapult. This is the catapult. Then the thread from the catapult. This is it. Then you have a stone here. And he gave the stone velocity 10 meters per second. And the angle at which the stone moves is 30 degrees. So if we look at it, it's similar to this. We are to find, resolve this into the vertical component. So this is 10 meters per second that the stone is moving. This is the angle 30 degrees. So from here, if we take this to be the vertical component, vertical, horizontal. So we have to resolve this vector into this component. Okay, from here, we say that the vertical component Vy is equal to the resultant sine theta, while the horizontal component Vr cos theta. So let's simplify and see. From here, you have 10 sine 30 degrees. And if you simplify, you will have 5.0 meters per second. Then from here, we have 10 cos 30 degrees. And if you simplify, 8.7 meter per second. So this is how we resolve vector, resolution of vector, using the examples we have shown here. Okay, the next we want to look at is resolution of more than two vectors. Here we just look at two vectors. How do we resolve when we have more than two vectors? So resolution of more than two vectors. For instance, you have up to 4 vectors. Let's say vector A, F1, acting in direction theta 1. You have another vector F2 acting theta 2. You have another vector F3 acting at an angle theta 3. Then you have another one F4 acting at an angle theta 4. How do you find the resolution of this type of vector? If you look at it, this is a bit complex, but it is not difficult. I showed you it's very, very simple. So to find the resolution of this type of vector, this x-axis, this y-axis. So to find the resolution, all we need to do is to, first of all, resolve into horizontal component and vertical component. Then from there, you add the horizontal component together, add the vertical component together, get a single vector for each of the components, then you apply the Pythagoras theory. And from here, you get the answer. It's not difficult. Then, to find the horizontal component, the vertical component, we must bear this in mind, that if vector is acting in upward direction, it is positive. And if it is in a downward direction, it is negative. Are we together? So when we are resolving for upward direction, we use the positive sign. When we are resolving the negative direction, the downward direction is negative. Also, if you are resolving to the right, it's positive. Resolving to the left is negative. If we remember very well, in plotting of graph, line graph, you look at the positive axis here, then this side is negative. Are we together? Positive axis here, then negative axis. So the same thing is applied in resolution of two or more vectors. So to resolve this very vector, let's look at it. Let's start from the horizontal component. Horizontal component. In the horizontal component, the total force, let's call it Fx, will be equal to F1 cos theta 1 plus minus F2 cos theta 2 plus minus F3 cos theta 3 plus F4 cos theta 4. All these are vectors, so let's put the sign on it. So this is what we use in the case of horizontal component. For vertical component, this is how we go about it. It's similar. Vertical component f of y, it will be f1 sin theta 1 plus f2 sin theta 2 plus minus f3 sin theta 3 plus minus f4 sin theta 4. Remember what I explained here, the sign. If you are resolving towards this, you have positive, downward, negative. That is why we see the sign, the negative sign. Are we together? Okay, so this is the approach, so that the resultant now, the resultant vector f now will be fx squared plus fy squared. So all we are saying is that if you have a complex vector like this, you resolve into horizontal component. This is the horizontal component fx, then this is the vertical component fy. So this is the resultant vector f, and this is the angle. So this complex vector has been reduced into vertical and horizontal component. And from here, we can find the angle. And the angle theta will be tan inverse. You remember, using Pythagoras theory, tan inverse vector in vertical component, horizontal component. So this is how we resolve two or more vector. This is how we resolve more than two vector, I mean. So first of all, you resolve vertical component, horizontal component. From there, you have this simple, then you apply Pythagoras theory, you get the resultant vector, and you get the angle. I hope it's not difficult. Okay, then remember this sign is very, very important. We use it to find the to know the component, whether it's upward, it's downward. So it's very, very important. You must remember it. Okay, let's solve example so that we will really understand what we are saying. Let me read out the question. Find the resultant and direction of the forces shown in figure 1. So let's look at the figure. This is figure 1. The forces F1 is equal to 7 Newton at an angle 30 degree. F2, this F2 is 8 Newton at an angle of 60 degree. Then this F3 is equal to 10 Newton at an angle of 75 degree. Then the last force, this F4, and is 12 Newton at an angle of 25 degrees. So we are to find the resultant and the direction of this force. Okay, let's look at it quickly. Let's look at how we go about it quickly. Remember, in the resolution, you resolve into vertical component and into horizontal component. So look, let's start from the horizontal component. Horizontal component. Okay, horizontal component. We have Fx. Fx is equal to F1 cos theta 1 minus F2. We are using the sign theta 2 minus F3 cos theta 3 plus F4 cos theta 4. So let's substitute and see. F1 is 7 Newton and the angle is 30 degree minus F2 is 8 Newton cos 60 degree. Are we together? Minus F3 is 10 Newton cos the angle there is 75 degree. Okay, let's proceed. Plus F4. F4 is 12 Newton. 12 Newton. Cos the angle here is 25. So if we simplify this, ensure your angle is in degree. you have 10.35 degree, 10.35 Newton. This is the horizontal component. Then the vertical component, Fy is equal to, I'm rounding up, is equal to F1 sine theta 1 plus F2 sine theta 2 minus F3 sine theta 3 minus F4 sine theta 4. Okay, let's substitute and see. So if you substitute, you will have 7 sine 30 degree plus 7 sine 30 degree plus 8 sine 60 degree. This is where we are substituting from. Are we together? Okay, minus 10 sine 75 degrees minus 12 sine 25 degrees. So if you simplify this, you have minus 4.31 Newton. So this is the vertical component. Okay, so this vector has been reduced into vertical and horizontal component. So based on this, the diagram, from this complex diagram, we say the vertical component is minus what? 4.3 Newton, and the horizontal component is what? 10.35 Newton. So this is the resultant, and this is the angle. This is the resultant force, and this is the angle. This is very simple now. Applying Pythagoras theory that we studied earlier, we can say that the resultant is 10.35 square plus, I hope you can see the board, plus minus 4.3 square or square root. And if you simplify this, you will have 11.21 Newton, which is the resultant here. Then for the direction, it will be theta equal to tan inverse. Tan is equal to tan inverse 90 minus tan inverse of F vertical minus F horizontal. So if you simplify this, you have 90 minus tan inverse of 4.30. Okay, let me take it up here. Say theta equal to 90 minus tan inverse of what? 4.30 over 10.35. So if you simplify this, you have 90 minus 22.56. So it will give us 67.4 degrees. So based on this, we have gotten the resultant and we have gotten the direction. Thank you very much for watching. Please like, share, and subscribe to my channel for more interesting videos.